Today we discuss the principle of moving coil galvanometer, that is, torque on a current carrying loop placed in a magnetic field experience a torque. That is, in the given figure we are showing that the current I is moving in the coil such that magnetic field is in this direction. These dotted lines are shown that dot lines are the perpendicular to the plane of the coil, and the magnetic field is in this direction. The initial angle between the perpendicular to the plane of coil and magnetic field is theta, I suppose. Let the length of this coil is L and the breadth of this coil is B. Now we know that force acting on a current carrying wire placed in a magnetic field is F BI sine theta. That is, I suppose in the first case, I suppose the wire PQ, in this wire PQ, the angle between current and magnetic field is theta plus 90. That's why we replace force on PQ is BIB, that is B is magnetic field, I is current, length of this conductor is B, and angle between them is sine 90 plus theta as shown. Now similarly, if we calculate the direction of this force, we can use right hand law, that is I cross B. If we do I cross B, the direction of force is in the upward direction. If the force is acting in this direction, in upward direction. Now similarly, when we talk about this length QR, the angle between magnetic field and current is basically 90 degree. This angle is 90 degree. Then if we apply the formula BI, length is L, angle is 90, then we can write that BL sine 90. And if we calculate the direction of the force on this wire, we do I cross B, that is I in this direction, I is in this direction, and magnetic field in this direction, then the thumb is in upward direction. It means that force on this wire is in upward direction, outward to the plane of the paper, that I written here, that is perpendicular and outward to the plane of the paper. Now we calculate force on the wire RS, that is R to S, that is I is in this direction, B is in this direction, means the angle between B and I is 90 minus theta. That if we put the value of force on RS is B, I, length of RS is again B, that is if this one is B, then this one is also B, then BIB sine 90 minus theta, that sine 90 minus theta is cos theta. If we provide, that is thumb rule, I cross B, then the direction of this is in the downward direction, means the force on PQ is in the upward direction and force on RS is in the downward direction, means these forces are basically equal and opposite, as force PQ is BIB cos theta in upward direction, and force that is force on RS is BIB cos theta in downward direction. Forces are equal and opposites. Forces are equal and hence cancel the effect. If we consider the last wire, that is S to P, then again the angle between current and magnetic is 90 degree. Then we calculate force on this wire, that is force on SP is B, that is magnetic field is B, current is I, length of this conductor is same as that of BIL, then angle is again 19 I and B, then this is BIL. If we calculate the direction, current is in this direction, we will rotate or curl our finger towards magnetic field, and thumb is in downward direction, that is direction of this magnetic field is perpendicular to the plane and inward to the paper. This I written here, this is the force is in inward the direction. In this case the force is like this one. Now if we redraw this figure, before redraw we can say that there are two forces, one force is upward, one force is second. They are cancel each other because their line of action is same. But in this case force on RQ is in upward direction, outward, and force on SP is in downward direction. Forces are equal and opposite, but their line of action is not same, as line of action of this force is in this direction, line of action of force in this case in this direction. We redraw this diagram, the top view of this diagram. This force on SP, is inward direction, force on QR is in outward direction. The this distance, that is, this distance is B. This distance is B. I draw here, this distance is B. Then this angle is theta. Then this angle is 90 minus theta. Then this one is theta. This is B. Then this is B sine theta. Then the forces are equal and opposite, but their line of action is not same. That is a force on SP I am showing here in the top view. The force in QR in this direction, that is in this direction. Then torque is either force into perpendicular distance. Force is BIL, or this one is BIL. Then that we take the perpendicular distance, that is B sine theta. And torque is BIL into B sine theta. Length into breadth is area. If n is the number of turns of coil, then we got torque is B and Ia sine theta. Current into area, number of turn into current into area is magnetic moment. If torque is MB sine theta, or we can say torque is M cross B. That's about the principle of moving coil galvanometer or any type of motor. Any type of motor can run with this way. Thank you.